introduce the jury members. Professor Li Jinlong from Zhongzheng Daxue, Professor Wen Jianhong from Lujun Guanxiao, Professor Wen Bingyi from Zhongzheng Daxue, Professor Zhang Zhenyi from Yangming Jiaotong Daxue. I chair this section. I'm Wen Xin from Taisida. So this section we have three teams. New case. Galileo and chapter T. All right. And so the chaplain of each team, please introduce your team member. Starting from the reporter team.
Honorable jury and students, we are Team Chapter T, and I'm the leader in Jiawei. And this is Ming Xi, this is Chen Shiru, this is Gen Shenyou, and this is Liao Ziji. Thank you.
Opponent team.
I'm the team leader of New Gate. Her name is Liu Yishen. This is Tyler and this is Hong Page.
Honorable jury and fellow competitors, I'm the captain from Team Galileo. My name is Wang Bingwei, Guo Yuan, Cai Renba, Lin Xuyao, and Gao Weijun.
Okay. Okay, so the opponent will challenge the reporter for the problem for 1 minute.
Choose number 3, siren.
So the reporter has commented to accept or reject.
We accept your challenge on number 3 siren.
Okay. Okay, so there's a preparation time for the reporter. Okay, 1 minute. So can you, each team write down the name of the presenter. Okay, so reporter gives the presentation.
Okay, hello everyone. We're Team Chocolate Team. I'm the reporter of problem number 37, and my name is Chen Shiwen. So here's our outline. So first, I'll show the problem statement and then the observation video. Then parameters of discussion. Then I'll show you the experiments and theory and then conclusion. Okay, so first problem statement. So if you direct an airflow onto a rotating disc with holes, a sound may be heard. Explain the phenomenon was investigated how the sound characteristics depend on the relevant parameters. So key point is the condition like airflows, rotating disc, and the target like sound characteristics. So here's our observation video. So this is our device or of the okay, this is our experiment. So this is the rotating disc, and here's the resistor, and here's the battery. Okay. Then after the observation video, we guess why the sound is formed. So as you can see, we guess that the audio frequency is related to air flux, and the air flux is related to the area overlap. So just like this graph shows. So at P equals 0, the air flow just didn't come through, and after the time passed, the air flow just come through, and this is rotating. So after 1/12 period, the airflow just didn't go through. So we can have this, and this is just like the standing wave of sound, and we assume that it's half lambda. So we can have this. And here is our experiment setup. So the disc and the resistor, and this is battery. Okay. Then here is the side view. So here is the motor that we made the disc rotate. Okay. So this is the virtual model. This graph shows how we measure the rotation speed. So we use a laser, and as you can see the holes. So every time the hole goes through laser, then the laser will show on the board. So we can measure the rotating speed. Yes. So this is our procedure. So first we dig a hole on the disc, and then we'll fix the center of the disc to the motor. Then we put battery on the box and connect the wires. Okay, then we measure the rotational speed, and we blow into the holes and record the sound. And we analyze the sound and change the rotation speed and repeat 1 to 6. So the way we change our rotation speed is like we change this. This is the variable resistor. Okay, so this is our experimental result. So the rotation speed is 14.2 round per second. So and we can have the spectrum like this. And this is 19.9 RPS, and this is our spectrum. This is 22.5 RPS, and this is 23.4 RPS. So we analyze the data. So as you can see, the rotation speed versus the frequency, then we can have this line. So it's really relative to the rotation speed. So okay, here's theoretical model and notation. So first, we assume that A of x equals the area that overlap, just like this, the orange place. So the airflow go through. And L is the distance between two holes, so it's like here to here. And x is the distance between holes and airflow. So we assume that this is the center of the airflow and center of the hole. So this is the center, this is the center. So here's x. Okay, so how do we analyze it? How do we use our theory? So we analyze the area, and we can have a function. Just something look like this, and after we got a function, we can Fourier transform it, and we can get the spectrum, the theoretical spectrum. Okay, so first, obviously, like in this graph, we can know that a of x is an even function. So we have a of x equals a of negative x, and equals a of L minus x. So this shows the period is L. Okay, so first we just said like a of x, when a of x equals 0, then we have x is between a and L minus a. So after we use Fourier cosine series, then we can get this equation. And obviously the a of x equals this, and then we assume that z equals this. So we can get an that's shown like this. So we make s of z equals this. So because s of z only has a numerical solution, so we can get the graph like this, and which a of x is dependent on s of z. So for the final phase we have this, and also x equals r omega t, which omega is the rotation speed, and r is the radius of this. We can have this equation. So here's our theoretic conclusion and prediction. So this is the theoretic amplitude and frequency. Okay, so let's fit the theory and our experiment. Okay, first like in our spectrum, that the peak is like 84, 169, and 253. Okay, so this is the rotation speed. So because every rotation, the airflow just goes through 6 holes. So we can times 6, and fit in this frequency prediction. Then this is our theoretical result. Frequency, and this is our experimental result. And this is when the rotation speed equals 19.9. So same, we have 114, and we have the experimental have 119. Then this is also the same. And this. Okay, so after the data corresponds to the theory, we have this equation. And so here's our conclusion. Due to the sparse and dense distribution of the air particle, the sound may be heard. And the theory matches the experimental data perfectly. And this is our theoretical equation. And this is our theoretical prediction, the frequency. And this is our experimental frequency. So here's the reference, and thanks.
Okay, have a seat. So, questions from the opponent.
So can I ask, how did you get rid of the background noise from the data you get?
Okay, let's have appendix. Okay, so after we, so that's just like we show in our spectrum. Now we can see that there's background noise. So we just measure the background noise like this, and we can see like the peak. This is 49, and this is 120. So we can fit here, and it's almost the same place.
But like for frequency, you can just subtract it. So you can just simply subtract it, because the difference between, for example, 70 and 90 hertz is 10 times larger. So you can't just simply subtract it. So
Okay, so what I just answered is, I said we measure the background noise, and so the background noise just formed here and here, the main. So we can we can say that this is caused by background noise, and the you said like this cannot be abstract, and because we didn't have a good tools to record the sound, so we didn't consider the amplitude.
And next question. That's a thank you.
Variation of the performance in 3 minutes.
Hello, dear professors and fellow competitors. I'm Typt from PF3 New Gates, and today the problem we're discussing is problem 3, SARS. So the problem statement is that if you direct an airflow into the rotating disk, which is filled with holes, a sound may be heard, and explain this phenomenon. Next is the review for the recorder. First is a theory. So audio frequency is caused by the airflux and holes overlapping areas. And the experimental factors are the rotational speed. And third is a conclusion. So faster rotation speed means higher frequency reproduce. Next is the strengths of the recorder. So first of all, compare. He compared experiments with the theory, which I think is great because you can get the audience into it. And second is theory presented clearly. Third, use of laser pointer so that we can see what he's talking about. Next is suggestions. So could explain more on the way sound is produced. And move on to discussion. So could you explain the theory behind sound production in more detail?
Here?
Yeah.
Yeah. Okay, so as you can see so this is our guess, and after we research our theory, then we said that I think this is the right way to, this is the way that produce the sound. So I can use this graph to tell you.
Yeah, sure.
Okay, so here's the hole, and here's our airflow. So if there's no air come through the hole, then here is just like normal. But after here's some air go through, then the flux, then like here. So when it's point like here, so when it just fit, when the airflow and the hole is just fit, then we have the largest airflow, just that go through. And then when it comes to like here, so there's no airflow. So we can assume that as like standing wave of sound. So it's the airflow caused by airflow.
So like when air goes through the disc, the spin of the disc brings vibration to the air.
Yeah.
And next question. Can you elaborate on the experiment setup? Because from setup, we can see that the disc is actually slightly shaking.
Here.
Yes.
Okay. First, I think it is because we use our hand to hold the camera to have the observation video. So I think the most of the shaking is caused by this. But like you said, the shaking. Maybe there's some shaking about it, like just like this. But I think the sound is relative like the angular velocity of the disc, but not the shaking.
So like, does the shaking affect it or not?
We don't know, but in my opinion, yeah, we don't know. We can't tell you direct answer because we didn't have this some kind of experiment. But because this we do our best to make it stable, but it just you said maybe there has some shaking. So, but in my opinion, I think there's maybe there's effect, but it's very low.
So like, there could be more improvements made.
Yes.
Next question: when you drill the additional hole to check if it's to check the rotating speed, what affect the center of its weight?
Sorry.
Because like normally when you drill holes, you make it like a pair, but you drill an additional hole to see the rotation speed. So like, does it affect the center of weight?
Yes, it's probably it's obviously it will change because like the rotation inertia will change. Okay, but in our experiment we discussed the rotation speed, and this is that we just measured during our experiment, so it's okay.
Also, you use different discs to check the rotation and different discs to set the experiment.
No, we use the same disk. Okay, first we use the same disk, and we use this variable resistor. Okay, so we change this, and we can change the rotation speed of motor. So we can change the rotation speed of the disk.
And next, so why is there a difference in statistics between the theory and experiments?
Okay, so I mean, here's the difference.
Yes.
2 to 3 hertz. So at first we think that just some errors because we don't have a perfect tools to measure the sound. But after we observe it, like we can say that it has like 5% error in the average. So sorry, can I use that word? Okay, thanks. So we think it's because of the velocity of the airflow. So we have the we will have this, and we have airflow go through.
Yes.
So we measure the frequency. We can name that is V over lambda. Right? Okay, so the lambda we have just in our okay. So you can like the time that goes through, so from this hole go to this hole. So we can have like okay, m times the velocity of the wind. Okay, so times the velocity of wind, and is so this v we can say this is the sound, the velocity of sound, and plus the velocity of we call VW. Okay, the velocity of the airflow. Okay, so I think it's called like this.
Also, you mentioned previously you think that the lambda behind after the wind goes through this is about one half lambda. And can you explain why?
Oh, okay, so here, so as you can see, when this condition open, and like there's a peak, right? There's a peak, right? There's a peak. So when the airflow comes from like this, go to here, then it will from the peak go to the down here. So this is we think that is the like half lambda.
And about the background noise, so that you assume that the background, because background noise have their range is not only in the former parts, there's also background noise in the further first.
Me here?
Yes. So you assume that these is an effect, these are not real.
Yes. So we can see like the mainly effect we think is this 2P. Okay. So but here we can avoid it because we can have a good environment to do this. So we can fully avoid the background sound. But in our experimental results that we focus on the peak that didn't exist in the background noise, like here.
And I can suggest you that if you don't have a comment for it, if you want to get rid of background noise, you can like turn the frequency into energy. Yeah, and you can subtract the energy because energies are subtractable, and you can add it so if you want, and then turn it back to frequency. And the last question is, could you explain like why is the highest peak of a frequency nearly always at 400, around 400 hertz?
So in our result we have this. So it's like times 2 times 3 times 4, and this is our round per second. So like you said, it's nearly like 400, but I think it just like because it times 6 and times maybe 3, 4, and it just go in the range from like 400 to 499. Like that. So like you see, the 930, 958, 963 is also.
So, like, what if you change the number of holes and the material used? Do you think that it will be changed, the highest peak of frequency?
You said the number of the holes,
Yes.
right? Okay. Obviously, I think yes, it will change because like every round we have 6 holes. So the rotation speed, so the RPS we need to times 6, and to get the periodic frequency. So like if I add the holes like 7 per, so every circle I have 7 holes, then it is times 7 like this. And you said
Highest peak of frequency.
huh?
Highest peak of
Has
frequency.
okay. So like in our theory, we have the theoretic amplitude, but just like I said, we don't have that environment to avoid all of the noise. So we don't have that tool to record the sound. So we didn't discuss about the amplitude.
And that's it. Thank you.
No, wait. You said change the this.
holes in this
No,
or
another.
material?
Oh yes, the material. And I think it didn't really affect it because I think it's relative to the holes and the rotation speed.
But wait, then if it's related to rotation speed, then why is most of the rotation speed, the highest frequency is around 400?
The most is
Because you said that you don't, you think it affects it, but almost all of it, the highest peak is around 400.
But I think this is the error that we record the sound. So it is not obvious.
But like in the background sound, the frequency with the highest intensity is usually around the 200, the 400 hertz.
What? You use a background or
Background noise. And use
no here's lower than 200. 400 here.
yes,
And then 200. So in our
background sound.
background sound is like if I didn't remember wrong, I remember that this is 49 and this is 120. So it's lower than 200.
It's more too. And thank you. I think that's it for this question.
Opponent will summarize this question in 1 minute.
So the first question, can you explain the theory behind sound production in detail? And he tells us about how the formula over the blackboard. And second, can you elaborate on the experiment setup? So for the setup, you can see that this is slightly moving, and he said that yes, first of all, the camera is shaking, but second, this might be a factor to consider. And we're circling through the additional hole to check its rotating speed. And he said that from your setup, they always check this, so it's not a big factor as well. So fourth, was there a difference statistics between the theory and experiments? So he said that it's because of a formula. And probably they were background noise, and they didn't consider changing it into energy. And last one, can you explain why the highest peak of frequency is always at 400 hertz, and they're not sure about it.
Thank you to our reporter and opponents here. I want to ask some questions. First is that you say the sound is caused by air force. Is that correct? And do the opponent agree? Is the sound caused by air force?
Is the sound caused by air force?
Like yes or no?
Yes.
Okay, thank you. And so, do you think it is like a compression wave? And like, it's okay. And the opponents, what do you think? It is like a compression wave.
We're not sure.
Oh, okay. And next, I want to ask, because you mentioned the shaking of disc, I want to ask you, so will the shaking of disc affects the results?
Well, certainly because the air is blowing into the hole, so the shaking
Yes.
of this can affect the flow.
Okay. And next, I want to ask, because you discussed about, did he use the same discs? So do you think it will also affect the results?
Well, if you use different discs and
Yes.
the time, like when you drill the
Like what will change? What parameter will change? Material? Okay.
Because it has to be drilled by humans, so
Reported.
I don't think change the material will affect
Okay. And next time to next, how do you determine your fundamental frequency?
so the fundamental frequency is like the first highest.
So you choose the first higher ones as the fundamental frequency.
Yes.
And the opponent, what do you think? It is proper.
we think that it's caused by the material.
Oh, another discussion. Okay. And next, I want to ask that: do you agree with the lambda that he defined during your discussion?
Yes.
Okay. And next, because from the graph I see that the intensity of noise is actually high. So why don't you consider the noise? Because I see that actually the noise intensity is high.
It's like here.
Yes. Why don't you have to consider that?
Yes, we consider, so we use the background.
And next, I want to ask, because there, as he mentioned, there is a 5% error in the in an experiment. So do you think that 5% error will be too large, or do you think it is okay?
I think it's okay.
It's okay. And next on to X, because you X, if you change the number of holes, it will affect the result.
Yes.
So if the number of holes increase, what will it affect the results? Will the frequency increase or decrease?
It depends. It depends.
It depends.
Yes. It depends on how the distance between the spinning.
No, I mean like
Yeah.
just change the number of holes.
Yeah, it
The
depends.
frequency increase or decrease?
Increase.
Increase. And next on to X. So because X about a higher frequency, always around 400. Do you have an opinion about that?
I mean, I speculate that it's due to the material used.
Yes. Okay. And for the noise, do you have a suggestion to? Oh, it's okay. Thank you.
Reviewer prepare presentation in 2 minutes. Okay, the reviewer presents.
Okay, so I'm a reviewer from Tinker. I'm going to review topic number 3, styrofoam. So this is the problem statement. When you directed an air onto a rotating disc with pulse, and you can hear the sound. So the main focus of the reporter will be the condition of the airflow and rotating disc and sound characteristics. So here's some of my summary and comments for a reporter. That's for a theory, he used an equation for sound frequency and discussed the air flux common areas of Hall and air dense distribution. And third is he used Fourier transform to get the graph. And for the experiment, he used some tools like motor, disc, laser for measuring the rotating speed. And for the parameters, he only changed the rotating speed. So here's his conclusion. That's when the faster the rotation speed is, the higher the sound frequency will also be. So he said that the theory will fit the experiment. This is some of my comments for a reporter that he has very good presentation and can explain how does the sound come out, and also comparison between the theoretical results and experimental results. But some of my suggestion will be he didn't consider environmental noise for the experimental setup, and also lack of parameters, only the rotating speed, and also some analysis through Fourier transform. So here's some of my comments for the opponents that he can well understand the reporter's report, and he can discuss about the noise in the graph, and also have discussion for the experimental setup and can find out some errors. But some of my suggestion will be the X parameters that the reporter didn't do, which I don't think it will help the discussion. And the second is she didn't organize the questions. So here's a review for the discussion. First question is that opponent X to explain the sound production. The reporter said it's different amounts of airflow cause the sound. And from my point, I think it is because of the compression wave. And the second is that opponent X, can you elaborate on your experimental setup? That the reporter said we use the camera to photograph. That's the reason of the shaking. Maybe I think maybe the reporter is right, but I think the hand shaking is not relevant to a sound produced. And the third question is that upon an X, you produce another hole. Does that defect? The reporters say maybe rotational inertia. And my point is that if the airflow is changing on the same position, the additional one hole may not be that significant. And the fourth question is that do background noise affect? Reporters say the noise is restricted in low frequency ranges. And my point is that the reporter has to verify this since the noise aren't always low. And the fifth question is that will the angular velocity affect the result? The reporter say yes. And from my point, I think that the angular velocity affects the time interval in which the airflow penetrates the holes, it can affect the frequency. So here is some of my questions. First is that is the sound because of airflow? The reporter say yes, where opponent say no, which I think I agree with the reporter, and also the airflow will cause the compression wave. And the second question is that is it a kind of compression wave? The reporter has no comment. Well, opponent say that maybe you could find a fundamental frequency. The third question is that can different disks affect the results? The reporter has no comment, while the opponent say yes. Maybe the material will change the result. And from a point of view, I also think that the dips of the disk will also affect the results. And the fourth question is that how did you determine your fundamental frequency? The opponent say he chose the first peak. And the fifth question is, do you agree with the wavelength reporter say? Opponent say yes, which I think it is correct. And the next question is, will numbers of holes affect the frequency? Both of them say yes, which I think that when the number of holes increase, the frequency will also increase too. So here's the conclusion. For the next point, I think the reporter didn't consider environmental noise into his experimental setup, which might affect the result. The second is fitting curve for harmonic, and the third is lack of explanation of generation of overtone. So here's some of my concepts revisited. First, I discussed about parameters like the rotating speed, and I fixed the experiment setup and some data discussion about the frequency around 400 and understanding the theories. So here's my presentation. Thank you.
Thank you. Concluding remarks by the reporter in 2 minutes.
Okay, so here's the concluding remarks of reporter. So, first summary of the report. I used Fourier series to match theory and experiment, and the experimental result matched theory and background frequency compared to experiments to show what peaks are from experimental data. Third key point to consider and improve that is that we have improvement in experimental setup, which is like avoid the shaking of the disk itself and the background noise, and yes, and try to avoid more effects and of background noise. So maybe like if I have the future, I have the chance to do it again. Maybe I will make a environment that try to absorb the background noise. Thanks.
Okay. So now questions from the jury.
May I ask the reporter a question? You said that the sound was formed by the standing wave. And if you want to form the standing wave, you need a reflection.
Wait, sorry.
A reflective wave to form the standing wave. How do you get this reflective wave?
Exactly. The reflect is the airflow that reflect by the part that is there's no hole. So hit the disk and reflect. You mean like that?
Okay, so that's your answer. Okay.
Okay, the frequency related to the speed of the motor, right? The frequency related to the speed of the motor, right? Okay. But suppose the speed the motor speed up, okay, the frequency will change, right? So how to make sure the base fundamental frequency change, not the motor speed change?
Okay, then we measure it. We do our experiment, and we have measure our sound, and during that we retest the rotation speed just at the same time.
Yeah. So I mean the background noise is very important.
Yeah.
Yes, because maybe the frequency change is just the motor speed change. Okay, right?
Yes.
More questions?
I would like to see whether the size of a hole matters. If you use a larger hole, will the frequency you heard change?
We didn't discuss in our experiment, but I think yes. No. I think no, it won't change. It will change another like amplitude.
Your opinion?
I think that if you change the size of the host, it will affect the sound volume. Yes.
I think the sound volume is mainly caused by the number of holes. So no.
So, any difference between using a larger or a smaller hole in your experiment?
We didn't discuss it in our.
I know.
So you mean I guess what I
You
think.
expect there cause any difference in your experiment?
In frequency, I don't think it will have the. I don't. It will affect the frequency, but I think it will affect the volume of the sound, which is the amplitude.
Because I think that if you change the size of the host, that's the air density wouldn't be the same. So that's when the hole is bigger, the volume will be smaller.
And I'm not sure if there'll be a difference, but if there is, I speculated that it may be, the frequency may get lower.
Can you explain in your spectrum data in low frequency region? There's in low frequency region. The intensity is quite big compared to is comparable to your noise spectrum. Can you explain why?
So you said.
In your spectrum, the low frequency region, the intensity is comparable to your noise spectrum.
Okay, so you mean compared to this?
Yeah, it's comparable.
Okay.
The intensity is comparable in low frequency region.
Okay, so here is our experimental error lab. We didn't have the direct distance between the microphone and in our experiment. So it has the different amplitude. You mean different amplitude like this and here? Okay, so this is our photo of our experiment, but in our results that we can see it didn't affect on the frequency that we want to discuss about. So I think it's just our experimental error.
Okay, I think time is up. Okay, so jurors, please prepare your score. Ready? Okay, so the scores for the reporter started from Professor Lee, 7, 6, 7, 8, 6. Can you raise again? 7, 6, 7, 8, 6. 8.那我下次从我这边过去。Sorry. Okay, better for the recording. Yeah. Okay, the scores for the opponent. Okay, so this time coming from this way. Okay, 6, 6, 6, 6, 8.
I'm sorry.
You want to make a correction? Okay. So let me try again. Okay. 6, 6, 6, 6, 7. Okay. Then finally, the scope.
Sorry, I think that the Mr. Li Rongjin scored.
Li Jinrong.
Sorry.
Yeah.
Li Jinrong, I remember he gave me 7.
First time is
But their type A.
Oh,
first time is 7.
it's 7. Okay. Okay, thank you. So you mean the score for the reporter?
Yes.
Okay.
First time is 7.
Yeah, okay, thank you for the corrections. Okay. All right, so finally, the scores for the reviewer. Okay, so this way. Nine, 7, 8, 7, 8. Okay, so this concludes the first fight. So second fight this afternoon. All right, as usual, the opponent team is here. Okay, they will challenge your problem for the reporter.
We'd like to challenge problem 8, Euler's pendulum.
Problem number 8. Accept. Okay, so reporter accepts. Okay, so the preparation of the presentation by the reporter. Yes, please write down the names of the presenter. In. Okay, the tutor gives the presentation.
Dear judges, opponents, and viewers, I'm a reporter from KGHS Newgate. Today I'm discussing the problem number 8, Euler's pendulums. So opponents basically, you take the plate of non-magnetic material and place a magnet on top of it. Then you suspend a magnetic rod and below the board and deflect the rod so that it touches the plate only with the highest and resistance. So we want to investigate this phenomenon. And on main point, the connection magnetic force and the number of magnets has placed both movement and stoppage time. So here's our observation. So we found that when different numbers of magnets are placed below the acrylic board, there is a difference in time that it takes to stop moving. And another observation is with different magnets on top, there is a difference in time that it takes to stop moving. So we assume that the numbers of magnets may influence the outcome. So here's our outline. So the theory is basically the combination of Euler sticks and simple pendulum. And Euler sticks is kinetic energy and angular momentum that turns into thermal energies, and it causes the things to stop. And there are two types of motion. First is rotation. And in this motion, the torque acting on mass is wings. And another is oscillation. The rotational force acts on mass is wings. So and this movement, the energy transformed during the oscillation, and the transformation between there's transformation between the kinetic and potential energies of the system. And there are two relevant parameters. First is length of pendulum, and second is mass of pendulum. And our determinant variables is numbers of magnets above the acrylic group and the numbers of the magnets below. And this is our experiment setup. So we basically put a acrylic board and put a magnet on top of it and a magnetic rod below. And this is our first variable. We change the numbers of magnets below the board. So we can see when we add the same amount of the number of the magnets on top of the board, and we increase the magnets below, the number of the time for the pendulum to stop increases. And we put two magnets on top. The result is the same as we increasing the numbers of the magnets below. The time for the pendulum to stop increases. And then we change the numbers of the magnets above. So when we put only one magnet above the board, and at the same number of magnets below, and we one magnet takes more time to stop than two magnets. And the weight increases the acrylic force between the magnets. So as we increase in the force, the time for the pendulum to stop increase. And these are observation of the amplitude at which the pendulum moves. It will decreases over time. And here's our discussion. The more magnets below, the longer it takes to stop. So more magnets below means more time. And the more magnets above, the shorter it takes to stop. And the more acrylic force in between, the longer it takes to stop. So strong magnetic force means short time. So here's our conclusion. The numbers of magnets and magnetic force both have impacts on the outcome. When a magnetic force is weaker or when there are more magnets below, the time it takes for the pendulum to stop is longer. And this is our presentation. Thank you.
Thank you. Okay, so questions from the opponent.
Okay, first of all, thank you for your thorough presentation, and the opponent has a few questions. First, please turn to the page that shows your first experiment. Okay, so here, can you explain what do you mean by average time?
And the average time is we conducted three experiments 3 times, and this is the average of
Time that it damps away.
Yes.
Okay, now please turn to the page of your data analysis. Okay, yes, the last page, data analysis. Okay. So here, it is obvious that the amplitude of the motion damps away as time evolves. So, so do you think that it is the area that caused the damping effect, or are there other reasons?
I think it's basically the enacted bounce
Okay, thank you. Now please turn to page 5 of your comparison between Euler's disk and your theoretical model. Yes, so did you consider the magnetic effects when you were using the model of Euler's disk? Yes or no?
Yes.
Okay. So here, here you stated that the rotation is caused by the magnetic effect, and the oscillation is only caused by the gravitational force. Is that correct?
Yes.
So, so can you briefly define your oscillation in this example? Like, what motion do you call it an oscillation? Between rotation, how do you separate the two examples?
Here's the rotation means the rod move.
You mean it performs a circular motion?
Sorry, time is up. I'm going to prepare the presentation in 3 minutes. takes the floor.
Okay. Honorable jury and fellow competitors, I'm the opponent from Team Galileo, and today I will be opposing question 8 Euler's pendulum. And this is the problem statement. And as the problem statement states, the problem requires us to release the rod with only the highest edge that touches the board. And we have to investigate the motion under various conditions. And the main focus provided in the reporter's report is the connection between magnetic force and the number of magnets, and has to do with the movement in the stoppage over time. And in the presentation, they investigated the relation. They have parameters which are related to the number of the magnets and the number of the acrylic board between the two magnets. And here is the outline of the report. For the theory parts, the reporter used the model of Euler's disk, and she also provided a comparison between the Euler's disk and the rod we're talking about. And also, he categorized two types of motion in his presentation, as she mentions, the rotation and the oscillation. However, to this point, we believe that the rotation, that the gravitational force can also contribute to the rotation, so this will be a part of our later discussion. And for the experiments, the tools they used are the magnets, and they conducted experiments with respect to different amounts of magnets to create different strength of magnetic. And they also used the acrylic boards as the distance between the two magnets. And the parameters they conducted is the length of the pendulum and mass of the pendulum. And these two, however, these two parameters, they may affect with each other, since that when you add up the length of the magnets, the mass can also change. And they also change the number of the upper and lower magnets to create different magnetic strength. And for the analysis, they showed a graph of tracker tracking on the oscillating motion. However, we believe that we do not see much data analysis with respect to different directions or the energy analysis behind the situations. And as for the conclusions, they stated that when boards increase, the magnetic force decreases, and when you add more magnets below, the longer time to stop the motion. And here are the comments for the reporter. First, they has a presentation is easy to understand, and they can show the number of magnets affecting results from graphs since they demonstrated the example under various conditions. And also, they have qualitative conclusion. And for the suggestions, we think that they should consider the mass that may change will increase the magnetic force, which means that when they add up the length of the magnet rod. And also, there weren't many quantitative theories to compare with the experiments. And next, they did not show the videos to strengthen the results and therefore hard to understand. And also, we believe that more graphs can be shown, not just the words that we've seen in the presentation. And these will be the discussion we will do for the phenomena. We will discuss the function of the acrylic board and the motion of the rod. And for the theory parts, we will discuss the chosen current system, and then the characteristics of the magnetic field, and also the comparison between the Euler's disk and the rod. And I'd like to start my discussion with the reporter now. Okay, so now please turn to page 5. Okay, yes, for this page. The next page. Okay, so here you have the model of the Euler's disk, and here you categorize the motion of the magnetic rod, and you categorize it as the rotation and oscillation, right? Okay, so now can you explain that? Can you briefly? Wait, what is it? Let me rephrase this. So can you explain again that what is your definition of rotation and oscillation?
So rotation is that when it's like the rod and release it,
You release it.
and they're aggressive energy the gravity, so it starts to rotate. And that generated with a magnetic force that creates the torque and
Okay, so you believe that, so in your presentation, do you mean that the magnetic force can cause a torque to the rod, however the gravitational force cannot act a torque on the rod? Is
I
that
think
what you're stating?
gravity also affects the motion of the rotation.
Okay, so it also contributes to the rotation, and can you now explain what is the oscillation mean in your presentation?
The solution is that so it, at first step, so we don't have the electrical velocity, so there's only there is magnetic force and also gravity to effect the torque, so it's that there is motion.
Okay, thank you. And now please turn to the page of your experiments. Okay, so here in your experiments, you tested under the time under 3 circumstances. And what is your release angle in this example?
Oh, we release the rod at
For
90 degrees all the time, everything.
Okay, every time. So are the results always the same?
Yes.
Okay, thank you. And so now let's go back to page 5. Okay, so can we go to the blackboard? So since you mentioned Euler's disk in your theoretical model, can you show me what motion of the Euler's disk should look like?
For early data, simply invest the LSDs.
Okay, this one. So in my understanding, an Euler's disk is the motion in which it looks like this. And this is you can understand it as a plate, and so it will rotate in this direction, so that it moves in this manner. So from here, since so in your presentation, since you mentioned this Euler's disk, so from my personal understanding, maybe the motion of the rod can be understood as an infinite these Euler's disks, and when they form a permutation, then we can have a rod. So this is my personal understanding, and what do you think about it? So now let's go to the page that shows your first experiment. I think we can go back there. Okay, so here you place the different magnets below, and from these results, and what can you interpret from this graph here? What happened when you add up the number of the magnets?
And the average time of the rod stop increases, and the thing that yes increases.
Okay, so when you add up the magnets of the rod, does that mean that you add up the magnetic strength of the magnets below?
Yes.
Okay, so now please turn to your conclusion. The last page of the conclusion. So here, you mentioned that strong magnetic force means shorter time. However, from your experiments, as you just mentioned, that when you add up the number of magnets, the magnetic strength increases, and so does the magnetic force. So from this thesis, then why does the time is longer when we add up the number of the magnets instead of slowing down, as stated in your conclusion?
When you put add more magnets below, so as it shows the time takes longer, and there's a stronger, and so it's magnetic potential energy
So
increases.
maybe you mean here is when you add up the strength of the magnets on the top of the credit board. Is that what you mean here?
Yes.
Okay, so I think that you should correct your conclusion as when you add up the magnetic strengthening on the upper parts of the acrylic board, then the stopping time, it might decrease. Now please turn back to the page the last page, the experiments page. Yes, okay. This one. So here we can see that the trend of the different experiments here slightly increases and here slightly decreases. And can you explain this trend?
I think it's because it looks off kind of sense and averages of evidence experimental error.
Okay, thank you. And by the way, what is the horizontal axis of this graph mean, since you did not mention in your presentation?
Thanks. This is only this is different variables, and we come back to frequency returns.
Okay, so now this is my personal understanding. Here, the vertical axis is the stoppage time, as you mentioned in your presentation. And are these the numbers of the magnets you add to the rod? Yes. What do these numbers stand for? 3, 4, and 5.
The number of magnets you added.
At the bottom of the rod, or at the top.
The bottom.
At the bottom of the rod. So so here is the time in here. So you conducted three experiments for one single. Okay, now I see. Okay, so now it seems that your experimental results every time is not always the same. So did you calculate the average error of these different status? So I think this can be included in your future work, that you calculate the data. Since from my personal perspective, this motion is really sensitive to its initial stage. So maybe a slightly difference in your initial stage might cause a difference in your experimental results. Okay, so here is the graph of the number of magnets and the average time. So here it seems that it is a line right here. So when you add up the number of the magnets, what do you think the trend it should be?
As we increase the number of magnets, the average time increases.
Okay, thank you. So now my last topic would be, since you conducted the experiments about you add up the number of the acrylic boards, right? So as you increase your number of acrylic boards, it seems that the period of the stopping time it increases. Yes. So and what is your opinion about that?
Because the magnetic forces is increased and create lower torque, and the collision frequency decrease, so the loss of its energy also decreases.
So it provides the magnets a more freedom to move in simple words. So that's the reason why it stops later.
Yes.
Okay, thank you.
Opponent summarize the discussion.
Okay. During this discussion, we had some discussions about the theory that refers to use of the Euler's disk. And from the opponent's opinion, we think that the rod can be viewed as a permutation of a bunch of Euler's disks. However, the opponent believes that the reporter should have a more thorough understanding about the comparison between the Euler's disk between the model in the experiments, since she included that as a part of her experiments. And for the experimental graphs, it seems that some graphs there weren't many meanings of the horizontal and vertical axis. The meaning were not specified. And the reporter also, it seems the reporter could not clearly explain the trends of different graphs. But she had a qualitative conclusion, which is mentioned in our last discussion, which is quite significant in this phenomenon and this discussion. Thank you.
Questions from the reviewer?
So I'm the reviewer for problem 8, and I would like to ask the reporter of the parameters of your experiments and your theories.
In our experiment, we only check the numbers and the numbers of magnets and the number of the acrylic board. And we did say that we use the parameters or like the mass and the length.
Okay. Proponent, do you think that the parameters that the reporter discussed are enough for the experiment?
Well, since as mentioned in the problem statement, there only requires us to attach the very upper ends of the solution. So I think for now it is sufficient to discuss the connection between the magnetic force and the rotation of inertia, which is the mass and the length of the rod.
Okay, so as we can see in the graphs that there was a decay of energy. So can you tell me what factors decided the decay of energy or damping?
In our experiment only investigating the time that it takes to stop. So I think that the work doesn't affect our results.
And do you think that what factors will affect the decay of energy?
Well, since when the rod it deflects from point to point, I believe that there are some factors of collision or friction that might, and also the air resistance that might cause the energy decay.
And in your theoretical model, you said there are 2 different motions. Then can you tell me what kind of motion are you talking about? Is it a pendulum or a cone motion? Okay, so then if it's a pendulum motion, then are there angular velocities needed to be considered in your theory? So do you think that there are angular velocity changes that should be considered?
Well, if there is angular velocity changes, which means it has an angular acceleration, which means there is a net torque that acts on the rod. And since that we always consider the torque acting on the rod as demonstrated in the presentation, I think it is significant to investigate the change in angular velocity.
And reporter, do you think that in your experiments, when you change your magnet's number, does it also change the magnetic force and the mass at the same time?
Since this part is only change only one level, so we are that to reduce the number of the magnet.
Time's up. Declaration reviewer. takes the floor.
Okay, so I will do my remarks on this the question of number 8. So first, we'll start with the pros and cons of the reporter. So the reporter did many qualitative results, and she had very clear experiment set of images, and the graphs showed a lot of qualitative conclusions. But some cons of the reporter are there's no observation video to show us how the phenomenon and how they did their experiments, and also there's no theoretical results, and lacks graph explanation. And also the number of data is not enough to prove their theories, and there's no quantitative comparison. And for the opponents, he asked a lot about the theories and experimental data agreements, and also he started an analysis on the Euler's disk, and also, but the opponents didn't discuss about more parameters that the reviewer failed to think of. So there are some points is that they both didn't talk a lot about the decay of energy and what factors causes it, and also the experimental setup is not actually very precise. So first, the opponent asked what causes damping, and the reporter's answer I didn't really get, but I heard mass. And for me, I think that aside from what the reporter said, also air resistance, friction, inelastic collision, and etc. And also, the opponent asked to explain the definition of rotation and oscillation, and the reporter answered that when they deflect the rod, it has an initial velocity. But also, the reviewers thinks that when the reporter said about their motion being a pendulum, then that wouldn't have an initial velocity. And then the opponent's question is, what is the initial angle? And the reporter answered 90 degrees. And the reviewer thinks that by using a machine to fix the angle, it would make the angle or the initial velocity a constant, making the experiment more precise. And also the discussion of Euler's disk, the reporter didn't answer. I think that the Euler's pendulum can be viewed as an inverted Euler's disk as a very, very rough approximate model. But the forces acting on the object would differ. And the opponent asked to explain the graph trend, and the reporter answered his experimental error. And the opponent asked what happened when we added the number of magnets, and the reporter answered period increases. So then I asked what parameters affect the motion. The reporter answered that the number of magnets and the mass, while the opponents answered that also the energy decay and the air resistance. And so I asked them decay of energy depends on what main factors. And the reporter didn't really answer, but the opponent answered as collision and air resistance and friction. And then I asked what kind of motion is the Euler's pendulum doing? Is it a co-motion with a initial velocity or pendulum? The opponent answered pendulum. And then I asked how angular velocity changed. The reporter didn't give me any answer, while the opponent said that it should be considered since there is torque acting on the pendulum. Then I asked while the change of the number of
Concluding remarks of the reporter.
Okay, so what I'm concluding is that in the rotating motion, that it will be affected by gravity. But in our experiment, we try to lower the amount of rotational motion. We did a movement more similar to the simple transit. And we wanted to clarify that the angles was always at 90 degrees, parallel to the acrylic board. And then when the magnetic force is added above, it shortens the time. And we should have added error bars and described the graph better and compared the release experiment. And we should also have edit experimental videos. And another theory, angular momentum to be discussed and maybe more should have been understood by the elastics. If we can control the material, we can put down only one parameter at once. And that's it. Thank you.
Okay. So questions from the jury. Mr. Lee?
Would you please describe the motion of the pendulum you observe in your experiment? It is really around the frame or it can rotate around the circle.
It is rotating in a circle, but the movement is really small and it quickly turns into jumps on the swing on one axis.
So both of kind of motion you can observe in your experiment.
But we want to try fix the pendulum on one axis.
In my opinion, there are two different motions. Is the pendulum twist motion and the cone motion that has an initial velocity. And there is a difference between these two motions.
Which case will take more time before stop?
The cone motion will take more time to stop.
Well, since I did not see a video shown in the reporter's report, so I can't say that precisely right now, but I think that before it stops, it should be an oscillation as defined in the reporter's report.
Any questions?
I think the problem pictures is basically the rotation and the swing motion. So I didn't see the experiment that shows this. So what's your opinion?
Well, I think the swing motion, as you just mentioned, it is the rotation in the reporter's definition, and the pendulum-like motion is defined as oscillation in the report.
So did you see the experiment that showed that?
Well, I did not see relevant videos or experimental cell.
In the problem statement, it stated that the pendulum is rotating, and from the reporter's report, we can only see it's being defined into oscillation or rotation.
We try to focus on the oscillation.
Any more questions? If not, I have one for reporter. So you study the time the pendulum stops, right? Okay, so that stop, is that a complete stop or an almost stop? Okay. Complete stop. In principle, there's no complete stop, right? Unless forever. Okay. So I'm just wondering, how do you justify the time to stop? That may be important. You can just give a quick answer, right?
We use the tractor to see this motion, and we define the stop as the movement becomes a line and will stop moving.
Okay, thank you. So do you have any opinion on the time to stop?
Well, I think that since we define stop, just as the jury mentions that there is no complete stop in the natural world. So even if we see it as a stop in our naked eye, there might still be some motion with the amplitude. So I think that the reporter can use a tracker to track the motion, and she can define as her own stop. For example, when the amplitude of the motion is less than 0.1 centimeter, then we can define this motion as stop.
As the jury said, there is no complete stop, so I also agree with the opponents by using tracker. And to define the stop using amplitude or angular velocity or angular momentum.
Okay, thank you. Okay. So this will conclude the competition. So now is the score. We'll have the scores from the jury. Everyone's ready? Okay, the score for the reporter, so this way. Okay. It's 5, 5, 6, 5, 5. 6, 5. Okay, next, the scores for the opponent. Seven, 8, 8, 7, 8. All right, and finally the score for the reviewer. 7, 8, 7, 6, 8. Yeah, thank you very much. Any comment from the jury? Okay, so this is going to be the third section this afternoon. So again, okay, the opponent will challenge a question from the reporter.
We would like to challenge question number 4, color line.
Question number 4.
We'd like to accept the challenge.
Accept. Okay, so please put the name of the dissenter on the wall. Yeah, reporter gives the presentation.
Okay. Honorable juries and fellow competitors, I'm the reporter from the Team Galileo, and today I'm going to report number 4, color line. And here's my common statement. When a compact disc or DVD is illuminated with a light coming from a film like that, and in such a way that it raise with large angles of incidence, and you may observe a green line. And the color varies along slightly changing the angle of the disc. And I'm going to explain and investigate this phenomenon in my following presentation. And here's my main focus. The first is the theories behind the phenomenon, and the second is how the different factors that affect the color, and the third one is the prediction of the color in different conditions. And here's my outline. And as for the observation, and when you make a light onto the surface of the CD, you can observe a green line. And under this situation, my further theory predicts the following series of wavelengths, which can be right down here. And here's my demonstration videos. When you can see the color changes as the light source moves. And another thing that you should focus on is that the light of the color will always bisect the angle between the light source and the observer. And as for my theory part, diffraction grating is an optical element which can separate polychromatic light into its constituent wavelengths. And the path-length difference can be written down in this expression. And when it equals to an integer times the wavelength, it will have the constructive interference, which makes us perceive the color. And another thing that we should focus on is that the structure of the disk. There will be a data layer which is marked with parallel tracks, and which can be seen as diffraction grating. As we know, the surface of the CD is marked with parallel tracks, and according to optics, an element with kind of structure is exactly called diffraction grating. And let's make a light onto the surface of the CD, and we can discover that each track of the disc will be a radiator, which means these waves will coincide, reinforcing each other, and that's why you can see the green line on the CD. And if there is a light source S and the observer O, when the light are incident on P or P prime, which is on the diameter of the CD, the observer can see the reflected ray, while in other cases like P double prime, the light ray will be reflected away from the observer. So that's why you can only see a color line on the CD. And by changing the light source S, but we can still observe that the color of the line was still at the bisecting line between the light source and the observer. And my explanation to this phenomenon is that when you focus on the diameter of the CD, there will be a periodic structure which makes the interference is easy to be seen. But when it's not on the diameter of CD, there won't be a periodic structure. And here's my own verification. And let's take a look at my model without inclination. And the length of the path, which equals to OP, can be represented in R, which has this geometric relation. And by the approximation of scatter diffraction theory, the observer at O will see the reflected rays can be satisfied with the expression of the electric field, which can be written down as this expression. Okay. And which you can later write down as E0 times E power IKR. And by recalling RF dimensions, we can finally obtain this expression. And since only a real part of the EM is considered, so a total electric field can be written down in this expression. And we can set S equals to IK tilde D in the by the partial sum formula, so the electric field can be written down in this expression. So, and by applying some algebraic manipulations, the total electric field can be expressed in this way. And another thing that is that since the light intensity I at O is proportional to E squared, and we can write down the formula of the light intensity, and which can later write down as this expression. And the left-hand side is when the lambda equals to D over M cosine alpha, where the M is the order of diffraction. So the intensity of the light will have its maximum, which is easier to observe the light. So this would be the curve of the light intensity formula. which is equals to a function of x equals to d over lambda cosine alpha. And we can observe that when x equals to an integer, the light itself will have its maximum. And let's take the situation of angle alpha equals to 0, which satisfies our condition in the observation. And this time we can get to component wavelengths, which finally give rise to a green light on a CD. And let's take a look at my model without inclination. And we can change my model into this formula, into this expression, and which the path length r prime can be written down in this expression. And beta here means the inclined angle of the CD. And by the same analysis, we can obtain these two formulas, which is a little bit similar to the previous one. And let's take the situation of angle alpha equals to 0, but beta equals to 35 degrees, for instance. And this time we have two component wavelengths, which finally leads to the magnetic color. And as for my simulation, I will use the previous formula and plug it into the Python and run with the simulation. And this is the simulation of the CD in different order, which can be seen here, 2, 3, 4, and each angle alpha and beta will correspond to a single color of the light in different order. And this is the situation when using DVD. And here's my experiment. My variables are mainly focused on the first thing is the angle of the incident, and the second thing is the distance between each track of the disc. And here's my equipment. As for my considerations, I want to is that the experiment should be done without other possible light sources, if possible. Okay, and I define my angle by using the spherical coordinate systems, which polar angle beta will equals to 90 degrees minus the inclination angle. And there will also be azimuth angle, which represented in flat. And these angle will satisfy this mathematical relation. And using this formula and plug it into Python and analyze the data, which is seen as you have seen my simulation. And this is an experiment of different width of the ditch. And I changed the parameters of the width of the ditch and measure the color of the line. And here's my control variables. And I will use CDs and the DVD as my diffraction gradient. And then I will apply my equipment on the tripod and make a line of incident on the diffraction gradient and compare the results. And this is the results by using CD, and I set phi equals to 0 degrees and changing beta equals to 25 degrees. And here's my simulation, which have 3 component wavelengths, and this is my experimental result. And this is the results by using DVD, and which can be seen there's only 1 component wavelength in the visible light spectrum. And here's my results by setting phi equals to 0 degrees and changing the beta angle. And here's my explanation to the result. The first is that the color of the CD and DVD are different, even they are in the same incident angle. And the second thing is that in my previous conditions, the CD will have a much more constituent wavelength in the visible light spectrum than the CD. So the composition of the color will be more complex to be analyzed. So owing to this phenomenon, my later experiments will be done by using only the DVD. And here's my experiment of different angle of incidence. And I change the incident angle, which consists of polar angle and the azimuth. And I will measure the color of the light. And then I will apply my equipment on the tripod and observe the color to see if the results will go by the theories. And here's my results by setting polar angle equals to 90 degrees. And I'm changing the phi from 20, 40 through 60. And here will be my experimental data and my theoretical wavelength. And by setting beta equals to 75 degrees. And here's my experimental results and the theoretical wavelength. And by setting phi equals to 60 degrees and changing the azimuth, and here's my theoretical wavelength and the azimuth. and compare it to my simulations when phi equals to 20 degrees and beta equals to 0 degrees. There will be a simulation which suggests it will be 393 degrees, and which you can compare it to my experimental data. And this is by setting phi equals to 20 degrees, beta equals to 15 degrees. And when changing beta equals to 30 degrees, the simulation will, and the experimental result will look like this. And by setting phi equals to 40 degrees, you can also compare my simulation to my experimental results, which is very similar to each other. And by setting phi beta equals to 15 degrees and 30 degrees, and you will have the same results. Okay. And because my preliminary observation, the inclined angle beta increases. The deviation, which means the cloud difference between each side of this, will ascend. And here's my results. In my results, the data seem to suggest that the most color line will match the wavelength as this predicts. But as preliminary observation, there's a color difference between each side of this, and here's my explanation. When beta is small, the angle difference can be ignored, which hardly affects cosine beta here. But when beta is big enough, the angle difference will be apparent, which leads to a apparent color difference. And here's my conclusion. As the distance between each track rises, there will be much more component wavelength in the visible light spectrum. And another result is that in previous experiments, my data suggests that most of the color of the line will matches this sphere predicts. And there will be color difference between each side of disk, which arises from the angle difference. And here's my references, and thanks for all of your listening. Thank you.
Questions of the opponent?
May I ask you, how did you pick the data of the RGB?
Pick the data of RGB. I use yourselves a tool in the PowerPoint which can show you the color RGB in single picture.
And, because there might be some different because different type of the camera. How did you fix the problem?
Since I know the camera of the phone will mostly satisfy the sensitivity of human's eye, and which I think that won't be too much difference.
The theoretical result might not be the same as the.
Yes, I only need to show you the color what it looks like.
So you haven't did the fix with the different.
Because when you know the theoretical, maybe for instance it will be equal to 400 degrees, 400 nanometers, and you will know it must be a line which is purple, and so which will not equal to something like green, and I only need to know that it is purple, and I think that is enough for my experience.
My next question is, how did you know your because there is not enough data for your experiment, and how do you know your experimental prediction of the Python is correct?
Yes, you can see in my yes, right there.
Okay.
And
Sorry. All right, preparation of the opponent. 看开关，没有关。那这个被关起来了。
那重开吗？
它会自动关掉。有空气了。
没有在没有遥控之前。
再开吧。关掉这样，不然还
I'm the opponent of problem for color line, and I'm from Team Chocolate Team. My name is Binchi. And talk about the problem statement first. When a compact disc or DVD is illuminated with light coming from a filament lamp inside the way that all erased with large angles of incident are selected. A clear green light can be observed. The color varies often slightly changing the angle of the disc. Explain and investigate this phenomenon. And the key point of the problem statement is that what's special with disc or DVD to produce color lines, and one makes various colors of lines. And here is the pros and cons of the reporter. For the first, the observation videos is the various color line and the wavelength of the green line. And the pros of the reporter is that he clearly shows the phenomenon, and the cons is he has partial lighting in environmental that may affect the experiment. For the parameters discussion, the pros is that he has complete parameters discussion, and the cons is that he didn't mention inevitable parameters such as environmental light and house to solve. And in the theory part, his pros is that offer many equations to discuss, and he had graphs for experiments offering clear results. But the cons of the reporter is that lack of explanation of different angles. And for the experiment part, he has a precise setup able to take discussion of angle convenience. And the cons of it is that lack of the explanation of data and graph, and the data amount is insufficient. The conclusion of the pros is clearly conclude the points of the experiment data, and the cons is that the lack of comparison between the experiment and the theory productivity. And here is my questions for first the phenomenon and the theory and others. So let's just give the. Okay, reporter, for the first question, I may like to ask you, in your model, there is in the graph which is in SP prime or something.
Just say it again, SP prime or something.
No, the SP double prime or the yes. There is another P double prime over here in your presentation, and I may ask you, when you change the angle of data in your theory, will the SP double prime and reflected in different ways?
It might reflect it in another way, but it won't change the fact that the ray won't reflect it in the eyes to the observer.
Can you explain that? Why doesn't that affect?
Because, okay, let's take a look at this picture. When the lights are incident other places like these, and it won't be
But I mean, when you change the value of data and reflected from the SP double prime will be changed in a different way. Will that affect your result of your experiment?
When you change your other angle, the diameter we need to focus on might switch from this to this.
Okay. My next question is why does the can you turn page 22?
Okay.
And as you can see, there might be values of sine square equals 0. And how can you explain that, or did that happen in your experiment?
No, I don't think it will affect my. Because we need to focus on is when this curve has its light intensity, its maximum of light intensity. So when x, which is d over lambda cosine alpha, we don't need to focus on. So when it equals to 0, you can plug it into this thing, and you can. But
no, I mean the value of the downward will never equals to 0.
You can take by using the method of limits, but my results of plotting this graph would suggest that when x equals to 0, it won't have something strange happens.
Oh, okay. For the next question, why isn't there any changes when the intensity of the light didn't change when another value of m? Will you explain why?
Because this sign, because the sign is a periodic wave, the sign function. So the combination of these sine waves will also be a periodic, which amplitude wave will not sometimes get bigger or slower or smaller. Sorry.
Okay. Can you explain me? You mentioned about the electric field in your theory, and
yes.
Have you ever tried to measure the electric field of your experiment, or maybe do something?
Yes, I do measure my electric field.
Did that show in your experimental results?
No, since you don't need to consider. You don't need to consider the electric field when you only need to focus on the color of the light, but it does derive the function from the electric field. But I don't need to measure something like the intensity of the electric field.
But this formula is based on the electric field, so why can you just keep it without consider?
Because when I need to measure the wavelength, I don't need. There's no parameters that suggest there's something about the electric field. There's only, as you can see, there's only alpha and the order of the diffraction, and d is the spacing behind these slits.
Okay. Talking about d, have you ever measured about your measure your d, or you just find it from your reference?
I found it on my reference book, but the CD had its material of the D, which when the list produced is not available, is not when D is not equals to 0.74 micrometers, it won't be a good CD. Then it would be regarded it will be discarded when the produced. So I won't purchase the CD of D equal the DVD of the spacing D equals to 740 nanometers.
In my opinion, I think the D may affect the experimental results a lot. So I think maybe you can use a thing like a microscope or something to actually measure the value of D.
Okay, I
Okay.
got your point.
For the next question, can you turn to page 44?
44.
Also
Okay.
45.
45, okay.
You have drawn like these features in your Python in your code. And can you explain me why the trend of the purple ones are decreasing and the red ones are decreasing?
No, I think that's not, because when you say the trend is increasing or decreasing, you mean there would be something like amplitude or intensity, but this is beta actually. So I think you might have missed the misunderstanding on my simulation. So would you mind let me explain it to you? Again?
My question, sorry, I fixed my question. My question is, what's different from this with this graph and this graph when the shape of the lines are different?
Okay, so when the lambda you derive from n equals to 2, for instance, and beta would equals to here, and the wavelength I derived will be out of the range of the visible light spectrum. So yes, so here's the results, and if you want me to give you a material explanation, I don't think it does matter.
Okay, as I asked before, how can you tell your model of your Python is correct when you just only have a few of experimental data?
Are you saying that how to make sure my simulation is correct?
Yes, how did you make sure?
From the results, I compared my simulations to the real theoretical wavelength. I think it would be a regular. So I think my prediction here is correct, and you can compare it. You can see it in other experiments, which I believe my simulation is correct.
But in the just like the data of this one, the theoretical wavelength and the corresponding wavelength are not quite matched when in some of the data. Can you explain me why?
You mean what kind of data? Because I've seen this data, which is my theoretical wavelength is 660, but the red light corresponding wavelength is ranging from 640 to 717.
Why is your wavelength corresponding wavelength is ranging?
Please can you restate your comment, please?
Why is your corresponding wavelength is ranging?
You mean the range of my corresponding wavelength?
What is there a range of your measurement? The measurement should be a value that is fixed. Why is there a range?
Because I don't have a spectrometer to really know my experiment data. Because the light of the color line is too hard to be detected by the spectrometer I use. So I would want to know whether it is what color it is and compare it and derive it in this wavelength table.
Okay. And in my in your observation video, there might be different kind of colors on only single one line. Can you explain why?
Okay, let me explain it to you. And my explanation to this is what I have mentioned. There will be the angle difference on the diameter of a single line when beta is apparent, when beta is big enough.
So you mean the value of the wavelength will change when your beta is in a different value?
Yes. When beta is in different value, my color will be changed.
And have you ever done this in your experiment?
I didn't did the experiment like this, but this is my explanation to the color deviation.
And can you predict what will happen when, just like the change of the color?
Okay. Theoretically, you need to measure the distance between the light source and the CD, as well as the
I want to check
the
trend. To predict what will happen.
predict. What kind of predict?
Maybe the changes of color.
The change of color, I can calculate the beta 1 and beta 2, and I can know what the color be like.
Thank you.
Opponent summarize the discussion.
Okay. At the first, I asked him about the phenomenon and how does the phenomenon colored in many types of. How does it have many types of color? And he answered that it's because of the diffraction. And the next one is about the theory. I asked him about what if the beta changes and the photo of his, just like the SP double prime will change, does it affect the result? And he answered me not. And the next question is, I asked him about his model and his, just like calculated from his computer Python. And I asked him about how does it matches your theory. He said, not enough.
Okay. So ask questions of the reviewer.
So first, the question is, what do you think are the most relevant parameters regarding this experiment?
In my opinion, I think the most relevant parameters is the incidence angle.
I think it was the angular and the distance between the tracks, just like D in his experiment, in his theory.
Next, what do you think will happen if a CD or a DDD has been burned before? Will it change the experiment results?
Can you restate your comment, please?
If the CD and DDD has been burned before, meaning it has
Yes.
data inside, will it change your results?
The unburned CD won't have the tracks on the CD, right? So it won't finally causing the tracks on the CD, which won't, there's no any diffraction rating. So I use a CD I use here is the burned CD.
And I think it might affect the range of the wavelength of the range of the value of M, because there is we can only see the visible light, and the light of the visible the wavelength are ranged in 400 to 700. So if he changed D, just like the distance between the tracks, and he will get a larger range to include many values of M.
On page 61,
61.
how do you think the color would change when beta changes?
Can you restate your comment, please?
How do you think the colors will change when the beta changes?
The beta change is just will satisfy this relation. I show here.
How would the color change like?
You need to consider the order of the M. So I think you need to give a number of alpha and beta so that I can calculate what it would be like.
What do you think?
I think it may make the different position of the CD trait will reflect different type of color like red or blue. Since its beta values are not the same as the original.
Okay. Preparation of the reviewer. Okay, reviewer takes the role.
I'm the reviewer from Team Newgate and the review for problem number 4, code line. So this is the problem statement of code line. For the reporter, they said the theory is diffraction grading. And the experimental factors that they use are the angle of incidence and the width of the niche, controlled by the CD or DDD. Their conclusion is that as the difference between the tracks increases, the more spectrums can be observed. And most of their data matches their formula. And there's a color difference on the two sides of the disk because of the angle difference. And the reporter, their theory was really well explained. It was very clear with many formulas. And they discussed the parameters for each theory. And the results was presented with a lot of statistics. They showed a lot of pictures, sometimes even videos of every experiment to allow us to have a clearer understanding. They then compared the experiment with simulation with their theory. But something I'll point out is it's a bit too fast because sometimes we need time to observe what you're saying, and it skips too fast and we can't get to what you're saying. Next, the opponent summarized the reporter's presentation very well. And he was able to catch some points that might have effect on the experiment, and they discussed on this. And the questions were asked regarding a lot of parameters. Like, they consider a lot of things in their question. And the discussion was very well planned. It was still a bit too fast because there was a lot of things to discuss, and some questions were not as essential to the experiment. In their discussion, they discussed when they change the angle with the way P double prime refracts change. And the answer was no, if P prime is not on the diameter, then it won't change. Next question is, in their formula, there might be values of sin squared equals 0 for this effect. And the answer was, using the method of limits, there won't be a 0 at the bottom. Did you measure their electric field? Yes, but it was not on the presentation because this was not essential. And did you calculate B? They said no, but it doesn't look that much. And what's the difference between the pictures when lights are different? It will be out of the visible light spectrum and it does matter. And how do you tell if Python's correct? They compared it with the observed wavelength, and it is really correct. Why is there a range in corresponding wavelength? Because it's from the data of the tracker. And there might be more than one color on the single line because of the slight angle difference. Does that change the data change? Yes. And can you predict the trend of color? Yes, they can calculate from data 1 to data 2. I asked what they think the most relevant parameters regarding this experiment is, and they both insert angle with the opponent saying this is tracks. And I do agree with them. And if the CD has been burned, will this affect your experiment outcome? The reporter said they use the burned CD because the unburnt ones don't have tracks. But if you use unburnt one, you can actually still observe the green line. And the opponent say it might affect the value of them. So in our opinion, only barely will affect the results. And the only thing it will change is probably the shade of the color. As the burning of the disc does not change the width of the tracks. And it only changes their structure a bit. And that's it for review. Thank you.
Thank you. Concluding remark of the
Okay. Thank you, the reporter, and thank you for very open discuss and the reverse review. And I'm going to conclude my discussion previously. And the first thing is the different camera uses, although there might be a little changes of the results, but I don't think it will affect the form of the color. And the second is that according to opponent's presentation, he mentioned there's some lack of a comparison, but I need to clarify that I indeed compare with Python. And the first thing is that the reporter want me to predict the color of the trend of the color. And I think I can calculate from the angle and the distance. And the fourth thing is based on the discussion with the reviewers. Okay, and I think, but I didn't do the experiment of the color deviation on each side of disk. But however, I think that I can plug the beta in my formula and calculate what it would be like. And the next thing is about our discussion revisits. And the first thing we did is comparison between a simulation from Python and the experiment. And the second is we discussed about the light intensity. And the third is the discussion on a Python graph and for a different shape of the color range. And the fourth is that the comparison compare the theoretical wavelength and the experimental wavelength. And the fifth is that the different color appears in a single line because the angle on the line is different. And here's all of my presentation, and thanks for your listening.
Thank you. Okay. Questions from the jury.
I'd like to ask you what the light source you use.
What kind of light source I used?
Yeah. What kind of light source you use?
Okay. I use the light source of filament lamp, which is mentioned in the problem statement. But when you did change the form of the color, I think it will affect the coherence of the light source, and but I think it would be.
I didn't catch you use the laser source or.
I didn't use laser source.
Okay. And the problem statement said you should use the line lamp. Did you use that?
Filament lamp. I used the filament lamp in my experiment.
So if you use the single laser source, what do you expect?
My sorry. My prediction of when using a laser, which is a single color light, and the results I've done, but I didn't put it on my PowerPoint. Sorry, but the result is it will still be a red light when using a red laser or red single light. Okay.
How about your opinion?
In my opinion, the type of the light source will affect the result of the experiment because there are many types like LED or the original light of, and they have different spectrum of itself. So I think it might affect the experimental results.
In my opinion, if the light source you use only consists of like one single primary color, then the color line you see will only be in that primary color. But if you use a light source that contains many different colors and it's a combination of colors, then we might be able to see different colors.
Can you still see green line? If you use a red, laser source.
I don't think when there will be a larger light color when using for instance the red laser.
Can you repeat your question?
If you use the red light only, you still see the green light as the standard.
Maybe yes, but the amount of the intensity of it might be decreasing.
I don't think so because I think the diffraction only, it doesn't change the frequency and the wavelength of the light that was input. It only reflects it into different angles.
Any other question? Okay, I have a question. Can you three comment on the limit of the angle of incidence of the light coming from a filament lens to have the green line observed? Is there a limit of the angle, incident angles? Just comment it.
Okay, I will explain in this way. You need to consider the different order, and you can set a given angle, like you set alpha equals to maybe 20 degrees for instance, and the beta will ranging from maybe 0 degrees to
Okay,
sorry.
you have a few already. Okay, good. Yeah, can reviewer comment?
I think there will be a limit.
Okay, so do you have any idea to estimate the angle? What's the opinion? Do you have any opinion?
I mean the angle of data might,
Yeah.
I think it will affect the result of the experiment.
How? Do you have any idea?
Because as his theoretical function, I think I see the cosine beta is above is on the top of the equation, so I think the value might affect the result.
Thank you. Any other questions? No? Okay, so we'll have scrolls for greeting.
Okay, the score for the reporter this way. Okay, 8, 9, 7, 8, 9. Score for the opponent. 7, 6, 7, 7, 7. Finally, the score for the reviewer. 8, 7, 7, 7, 8. Okay, so all three teams do a good job. Okay, so this